Doug, thank you very much. It's a real privilege for us to have you here in New Zealand. And I shall ask, like many Kiwis wonder, why Multicore World?
Well, I've been watching this conference for several years now, and all the leaders in HPC have come here. And this is my first time here, first time to New Zealand.
Hopefully not the last.
I hope not the last. Beautiful place, but also when you look at the speakers that you have here and the participants, it's all the leaders in this field, and it's important to network and get to meet and know everyone and interact, and particularly get feedback on what we're doing, how can we work together, collaborate.
And you think that feedback is easier to find here rather than anywhere in the United States where everyone lives closer?
Well, I would say yes and no. Yes, meaning there are people that attend this conference that I don't regularly interact with, so it's really important to reach out internationally. I say no in that you and I see each other at supercomputing and international supercomputing. There's certainly other venues, but this one, I like the fact that it's intimate and smaller group, be able to have more time together to talk about collaborations.
Speaking about collaboration, you're the director of the Exascale Compute Project, which perhaps outside the United States or in the major economies sounds like a little bit far-reaching, but we know in the industry that collaboration is paramount, and we from the open source world also know how to build things in the long term. Isn't still an imbalance between the largest economy and small economy? I'm talking about beyond the scientific collaboration in academia. In the same way that DARPA led into the internet, how can we from New Zealand, particularly from government and industry, piggyback on top of the ECP and vice versa? How could you benefit with whatever innovation that we can trigger?
It's a very good question. So ECP is for the most part a large software project, and most of our software development is open source. In fact, our entire scientific software stack, which consists of 100 separate components, is open source. And so we've got what we think is a scalable model to collaborate and work together. And so we hope that the scientists and engineers here in New Zealand will give that software stack a test drive and work with us. We've got a model where you can contribute into the software stack, both on existing components but as well as add components. The idea with ECP was certainly to lower the barrier of entry into these complex hardware architectures and be able to essentially democratize what we're doing.
Yes, but you say about 500 times speed up in the last 5 or 7 years, and sometimes for industry to adopt that, because we have legacy systems or supply chains, and sometimes the pragmatic New Zealander entrepreneur will say, well, why should I go as fast if I don't have nuclear models or whatever to follow? Which would be the angle? Because what I'm trying to figure out, why are we always technology takers?
It's a good question. So in ECP, we're not just about getting the same answers faster. All of our development work across the board is focusing on better science models, better algorithms, better software, all combined. So our metrics for the project are delivering higher confidence solutions, and that exascale gives us the ability to do higher fidelity, resolve more link scales, time scales. So we're not just interested in, frankly, never interested in the same answers faster.
Correct.
And so a lot of the base technologies we're developing are open source and available, and I see, since I've been here, some real synergies with some of the focus areas here in New Zealand with what we're doing in the States and the Department of Energy.
Fantastic. Well, I look forward to collaborating. Thank you very much for coming.
I do too. Thanks, Nicholas.
Okay.